Of course, we already talked about statically indeterminate systems, but now that we have a much better understanding of why we can calculate statically determinate systems and why not statically indeterminate systems and what makes a statically determinate system, it's also good for us to formalize statically indeterminate systems. So statically indeterminate systems, as we alluded to before, are systems that cannot be solved anymore with our three equations and our three unknowns, and also we don't have enough boundary conditions to solve it simply based on our free body diagram. So for example, this would be the very first indeterminate structure that we cannot solve anymore because it's not a compound structure, because we have 1, 2, 3, 4 support reactions, but only 3 equations that we can solve them with. And so that does not work. And of course, we can draw structures in any shape or form. In fact, let me actually make some random shapes up here. So for example, let's say I have a structure that looks like this, and then maybe like that, and I have a support here, and then maybe I have a support right here. I have a support right here and a support right here, and maybe I even have one under a random angle here. And so now the one thing that you need to understand about statically indeterminate systems in this class is how many times is it statically indeterminate. So can you guess which the degree of statically indeterminacy is for this system? Go ahead and do it, and after you finish pausing the video, I'll solve it for you. I have 1, 2, 3, 4, 5, 6, 7, 8. And so this is to the 5th degree, right? So 5 times statically indeterminate, so 5th degree. And so you need to be able to identify how many times is it statically indeterminate and why you cannot solve this. Let's make 1 or 2 more systems that are statically indeterminate. So for example, I can have a cantilever that may look like this, and then I weld another structure to it. So let's say something like that. And maybe I even build a system on there just to teach you one more thing about statically indeterminacy. And let's say that looks like this. And so now be careful, right? Because here you actually have a statically determinate system on top of a statically indeterminate system. So what I'm trying to tell you here is that this is your hinged, simply supported frame that is statically determinate, and it just sits on top of the structure. So this is just adding forces to the system. So this is not counted in my statically indeterminacy, but I have 1, 2, 3, 1, 2, 3, 6, 1, 2, 3, 9. And so this is to the 6th degree, right? And I want you to understand that all these systems here are statically indeterminate due to their support reactions. And support reactions are technically external forces, and so therefore we call this system externally indeterminate, right? So they are externally indeterminate, and that should tell you something that is beyond the purpose of this class, but later on in your engineering career you might find that there's not just externally statically indeterminacy, there's also internal statically indeterminacy. And just to give you a flavor of what that means, so let's say you have a cantilever beam that is standing like this. So this, of course, you know, is statically indeterminate because you can calculate it. And now to explain to you internal statically indeterminacy, I want you to consider the following. So I'm going to weld something to this cantilever beam. So this is a rigid frame. Think of it as being made from metal. And as of right now, this is a completely statically determinate system because everything is free to move and there's no restriction. But as soon as I come in and weld this together, so let's say I weld something on here and I rigidly connect this, I have a problem that engineers have to address, and that is that now this system here is connected rigidly, which transmits the forces from one part of the structure to another one. And you can see this is kind of like a closed frame. So think of heat being added to the system. What happens if you add heat to it? Every part of the structure wants to expand. It wants to become longer. And therefore, the forces will actually transfer from one part of the structure through the welding to the next part. And so this would be outside of what we need to understand here. This part is not something we talk about, but this would be an internal statically indeterminacy. So this is an example where you can actually have a statically indeterminate system, not due to its support reaction, but simply due to the fact how it's connected within itself. So you need to differentiate internal and external systems, or statically indeterminate systems. And in this class, you don't even have to calculate statically indeterminate system, but you have all the knowledge you need to understand how often a system is statically indeterminate, or better said, to which degree. And this is part of this class. You need to understand how often the system is statically indeterminate. But with that said, we now have covered everything we need to know about connected systems or compound systems, and we understand statically indeterminacy and statically determinate compound systems, so that now we can actually go ahead and apply the knowledge that we developed here for these systems to example problems, and we can now go ahead and calculate compound systems that are either not hinged or hinged together. And we will do that in our next upcoming problems.